Hey, how's it going? Another quick little tutorial video on how to put together some circuits. So the first thing you're going to want to do is get to the PhET or PhET from University of Colorado website. You can just do a search for those four letters to first hit, or click on one of the links that I'll put in. Then go to Simulations up here and Physics. Then following down here we go Electricity, Magnets, and Circuits. And then we click on the Circuit Construction Kit Virtual Lab. And then hit the play button here. And then we see we have our sort of sandbox space in order to build these. I did this in one of the earlier videos, but I thought that I'd make a separate video just on this so you didn't have to sift through one of the previous lessons if you forgot where it was. So on the left-hand side, we have a bunch of options that we can click and drag onto the blue space anywhere we want, and it's just a click is how you can move these things around. Two connectors on either end. Circle these dotted lines will be in red if there are no connections, and they will become black once a connection is made. And then we have this little scissors here that if I click on a connection, I can hit the scissors to disconnect. So I can drag, let's say I have my battery and my wire to connect on here, and then I can resize. You see that it's become black, meaning that there's a connection here, but again, these ends are still red, showing us that we have not completed the circuit yet. If I wanted to disconnect, I can click on the scissors, and then I have two different pieces, and then just re-drag to connect. Alternatively, you can also just hit the delete button when you've clicked on a connection, and that will sever the connection. If I want to get rid of something, I can also hit the delete button. Or I can click drag, and if I click drag, or if I click on it, once it's outlined in yellow, I should be able to click the garbage can and it will go away. So lots of different ways to do things, whatever allows you to be fast, I guess, as it were. I'll show you how to make a simple series and parallel circuit, as well as use the voltmeter and ammeter on the right-hand side, and show you how to change some of the stats of these guys, okay? So on the left, we drag these different things. We have a whole bunch of different things ranging all the way to dog, which is kind of fun. So if you want to play around with it, then please, by all means. These you don't really need to change. Show current as either electrons or conventional. Please leave electrons. The conventional current will be too confusing for us at this point, and we've been talking about electrons, and so please make sure that electrons, these little blue dots, is circled. Labels is fine because that just takes off the names of them, so I'd leave the labels. And you can put values on too to save yourself a little bit of time if you'd like, but I'm going to leave that unchecked. With the voltmeter and ammeter here, we also click and drag. If you want to get rid of the voltmeter though, there's no delete button. Drag it back over here and let go, and it will kind of get back into the box. Same thing applies for the ammeter. I guess we can get rid of it that way, and it will return here. Let's build the circuit first and then look at using these voltmeters and ammeters. Okay, so let's make just a series circuit with just a light bulb in it, nice and easy, okay? I will make this so it looks like a rectangle, but you actually don't need to make the connections, right? The way that the wires would be sort of in real life. So what I'm doing is I'm going to be adding more wires. You can see that down here, I've dragged two wires, but really this would all just be one. It would be the same wire. I just get a little less functionality because it only can go diagonal. So if I want it to go at a right angle to make it look neater, I'll be using two different wires. You don't have to, but I would recommend doing it like this until you're comfortable looking at this, getting a bit more practice, because it will look very messy. And if you make a mistake or if something doesn't work, it'll be harder to see where you made the mistake if you don't keep it neat and organized. So let's, like I said, let's make that series circuit with just the light bulb in it. And we're done. We see that my circuit is complete. All my dotted lines are black, which tells me it's complete. And then I see that these little dots, the electrons, are moving. So you notice the conventional goes the other way, which is too confusing for us. Let's please focus on this. So what this means is that this battery here, the black end of it, because electrons flow from the negative terminal to the positive terminal here. So this negative terminal, so basically the black side of the battery, this is negative, and then this copper, it looks like a Duracell battery, this or orange part of it is the positive, right? That's where the electrons are going to. And then they flow through the filament of the bulb here. And we also see that these little lines here are telling us that the bulb is shining. Okay, our series circuit. Let's look at some ways that we can change some features. If I click on this battery, you notice that a little slider comes up on the bottom with some buttons as well. I can trash it. I can flip the battery, so I can actually change the terminals to alter the direction of the electrons. Just leave it the same. We don't need to use that, but just that's what that flip means. And then down here is the slider for changing the voltage. If I increase the voltage, you can see that the lines increase, meaning that there's more energy going to the light bulb, which means that it's going to glow brighter, right? And you can increase that to 120. If you want more volts, you can use this battery with the little lightning bolt on it. But we don't need current quite that large, so we'll just drop it back down to something a bit smaller. But this is how you can alternate the voltage of the battery. Notice that you can't change the number of cells in the battery. We're not going to be too interested in how many cells. Some of the examples that you were using will tell you the number, because when you notice that in our circuit diagram notation that this is just a one cell, right, is all that we're dealing with. But we will ignore it for now. Now, we can also change the resistance on the loads that we put in here. So remember that the light bulb will have some resistance. These wires, the resistance of the wires will be negligible, right? So we can't change the resistance of them. And we're going to assume that the resistance here is probably going to be pretty close to zero. But the load, or the light bulb, is converting the electrical energy into something else. So we're going to have a little bit of resistance there. And you can change the resistance by sliding up to the number of ohms. And so you can see, oops, as I break my battery, that the current, or the sort of the speed of the electrons is at a particular rate when it's at 5 ohms. If I increase the resistance, the electrons have slowed down. So you can see some of the principles that we were talking about in the lessons in real time here, because this is how these things would behave in real life, which is the nice thing about the simulation. So 2 ways we can alternate the resistance of the loads as well as the voltage of the power source, right, of the battery. Let's take a look at how we use voltmeters and ammeters now for when we connect them. Remember that remember that voltmeters can have to be connected in parallel. Well, you notice that the connectors for the voltmeter are different. There are these different leads here. We don't actually have to connect them anywhere. We just have to hover them over some materials in the circuit. When I hover my negative black over one side of the battery, my voltmeter is connected in parallel because I have an alternate pathway. I don't see the electrons flowing through the voltmeter though, so that might be a bit misleading, but I still have a reading here. If I don't have it connected properly, you'll see just the question mark. So you'll know that it's correct once it actually touches the wire. And there's a pretty wide range there, so it doesn't have to be too specific for the tip. And then you can also see that I'll get a voltage of 0 if I have them on the same side. So remember, they need to be across something. The voltage of the battery, right? So I can see that my voltage of the battery is reflected in the voltage of the voltmeter here. So all the voltage is going into this singular bulb. So that's how to connect the voltmeter, or how to measure the voltage across something. Similarly, with our ammeter, we will plug it in and measure the current. Now, what makes this a bit trickier is we actually have to connect this in the circuit somewhere. Remember, this has to be connected in series. So if I wanted to measure the current going into the light bulb, I could disconnect my circuit, and then I would reconnect either side of my ammeter to connect to the bulb. And I can see that I now have a reading on my ammeter of 1.78. Notice that the current will change. If I increase the voltage, the current is also going to go up, right? Series circuit, I'm going to drop the voltage down, and my current is also going to change. With a very high current, though, another way I could affect this is if I increase the resistance of the light bulb. Notice that the current slows down overall if the resistance of the light bulb is increased as well. So different ways that we can play around with this. The current will stay the same, but if I get rid of my ammeter, the circuit will function in the exact same way, but I just will not be aware of what the current is. Okay, perfect. Let's create a parallel circuit now to get an idea of how we're going to do those and just show you roughly how to connect them. I have my series circuit. In order to create a parallel circuit, I just have to branch off a pathway, creating a choice for electrons to go. This second pathway will also only contain a light bulb, just to make things easy. Now I have two bulbs each going through. They have different resistances, so let's make them the same, so it's consistent. So each light bulb has the same resistance, just to make things a bit easier, and you can see how I've made this branching pathway. To sort of further show you how this is going to work, if I add a switch into this one pathway, I can now control only this light bulb here, this what I would refer to as the second light bulb. If the battery is here, this light bulb that's closest is the first, this light bulb over here is the second, right? And this is this first pathway is pathway number 1, and then this pathway is pathway number 2. Notice that if I open the switch, this light bulb does not turn off because it is a parallel circuit. So I've added a switch that only controls this second light bulb, not the entire circuit. Let's try and create, if you're doing this along with me, why don't you pause the video and try and make a switch that controls the entire circuit. Alrighty, so you probably made something that looks like this. And voila. This switch now controls the entire circuit because if I close the switch, both light bulbs turn off. I'm not violating any of my properties that I was talking about, but remember that it does depend where the break of the wire is, so that just because there's a breakage in a pathway does not mean that all the bulbs will stay on in a parallel circuit all the time. In a series circuit, it doesn't matter where the breakage is, it will always shut all the bulbs off. But you can see that in a parallel circuit, it does depend where the switch goes that will determine how we can control it. So this switch up here is actually connected in series before this first branch occurs. But if I were to put the switch at any point after this branching point, even along this first wire, I can control each individual light bulb that way. So you can see really the versatility of a parallel circuit. So those are all the features of the simulation here. Hopefully that is enough to get you through. If you have any questions about how to use these things, please let me know. Let's look at the voltmeter quickly. So I put the circuit completed. I'll bring my voltmeter on again to measure the voltage of this light bulb. I drag the leads like this, and I can see my voltage here of 36. And then again, if I bring it down here to either side of this other light bulb, I can measure the voltage of that light bulb. If I want to know the voltage of the battery, I bring either lead to the other side of the battery to show you there. Similarly, ammeter, if I want to measure the current at one of these bulbs, disconnect my wires and then reconnect them so that the ammeter is there. I can directly connect these two together, which is okay, but it's probably better to use a wire so that you can see it clearer, right? So the current of this first bulb is 3.6, right, on this one pathway. So the ammeter here is connected in series, right? And I'm measuring the current for the first bulb right now with it in this position. If I wanted to measure the current of the second bulb, move the ammeter, disconnect and move the ammeter down to this pathway down here. If I wanted to measure the current of the whole circuit, I could move the ammeter up to here to see directly the current coming out of the battery before it gets branched out. All right, that's it for me. Let me know if you have questions.